Hey everyone, welcome back to my channel Security Bit. The reason we are talking about what these large language models are under AI Security Podcast is because we need to know how these systems actually work before we can protect them against their security risks. Just like you can't secure your house without knowing how doors and windows work, you can't secure AI without understanding how it processes information and makes decisions. So, welcome to this episode and enjoy yourselves on my channel Security Bit. Please note that this podcast uses audio which is AI generated, but all the content is vetted by a human, which is me.
Sometimes it feels like the tech world is throwing new terms at us faster than we can keep up.
Tell me about it.
And right now, large language models, or LLMs, they're definitely having a moment. It can sound pretty intimidating.
Yeah, it can.
But for this deep dive, we're going to try and make it simple. Our mission, really, is just to give you a clear picture of what LLMs are all about, and maybe more importantly, what they can actually do for us.
That's right. And we've pulled together a really useful set of resources, I think. We've got articles from places like Luminalta and TechTarget, industry hubs, looking at the practical side.
Okay.
Then there's a key research paper, Attention is All You Need. Sounds a bit dramatic, but it's fundamental.
Right.
Plus a Wikipedia overview, a good explainer from Understanding AI, and even some chatter from Reddit about real-world challenges people face.
So a mix of the theory and the practice.
Exactly. The goal is that by the end of this, you'll have a solid grasp of LLMs, what they can do, where they're popping up, without getting totally lost in the jargon.
Perfect. Okay, so let's start right at the beginning. What is a large language model in, plain English?
Okay, so think of an LLM as a really, really smart AI system. It's designed specifically to understand, generate, and kind of manipulate human language.
Language specifically?
Yeah, text mostly.
Okay.
It's a type of machine learning focused on natural language processing. So think language generation, translation, that sort of thing.
And the large part, what makes them large?
Good question. It refers to two things mainly. The sheer number of internal connections, these things called parameters,
Okay.
and the absolutely vast amounts of text data they're trained on, like huge chunks of the internet, books, articles.
Wow.
And they learn this using something called self-supervised learning.
Okay, self-supervised learning. Break that down for me. What does that mean in practice?
Right. So it basically means the model learns from the text itself. It doesn't need humans to label every single piece of data.
How does that work?
Well, a common way is just predicting the next word in a sentence. It sees billions of sentences, and it constantly tries to guess what word comes next.
Ah, like filling in the blanks on a massive scale.
Exactly. And by doing that over and over, it starts to pick up on grammar, facts, reasoning, even biases present in the data, unfortunately. It learns the patterns of language.
Okay, that makes sense. It's learning by predicting. But how does it actually understand meaning? It's not just memorizing sequences, is it?
No, it's deeper than that. It represents words using numbers specifically, lists of numbers called vectors. Think of an imaginary word space.
An imaginary space, like a map.
Kind of, yeah. Words with similar meanings end up closer together in this high-dimensional space. Like, think of coordinates on a map. Washington, D.C. and New York are close geographically, right? Their coordinates would reflect that. Similarly, in this word space, the vectors for, say, happy and joyful would be close. Happy and sad would be further apart.
Okay, I get the closeness idea.
And what's really wild is you can do a sort of math with these vectors. The classic example is take the vector for king, subtract the vector for man, add the vector for woman.
Right, then you get...
You get a vector that's remarkably close to the vector for queen.
Whoa, that's actually incredible. It's like it's learning analogies.
It's learning semantic relationships, yeah. But it's important to remember these relationships reflect the biases in the text it learned from. That's a whole other challenge.
Right, okay. Bias is a big topic there. But sticking with understanding, what about words with multiple meanings, like bank?
Great point. LLMs handle that too. They don't just have one fixed vector for bank. They look at the context, using the surrounding words. So money in the bank versus sitting on the riverbank, the LLM generates different vector representations for bank in each case, capturing the intended meaning. Same for magazine, could be a publication or part of a gun. Context is key.
So context is everything. How do they keep track of all that context, especially in longer texts?
Ah, well, that brings us to the core technology behind many modern LLMs, the transformer architecture. This was introduced in that attention is all you need paper we mentioned.
Okay, transformers, what do they do?
So imagine the text goes in, it gets turned into those word vectors. Then these vectors pass through multiple layers of, well, transformers.
Layer by layer.
Exactly. Early layers might focus on basic grammar, figuring out nouns and verbs, resolving simple ambiguities.
Uh-huh.
As the vectors go deeper, the later layers build a much higher level understanding of the whole passage, how all the ideas connect.
And how does information flow between words? You said context was key.
Right, through a mechanism called attention. This is the clever part of the transformer.
Attention.
Yeah. Inside each transformer layer, there are basically two main steps. The first is this attention step. Think of each word vector looking around at all the other word vectors in the sentence, or even further back.
Looking around.
Okay, analogies help here. Imagine it's like a matchmaking service. Each word sends out a query like, here's what I'm interested in understanding better, and it also has a key, here are my characteristics.
Right.
The network compares the queries and keys between all the words. When there's a good match, meaning two words are highly relevant to each other in this context, information is allowed to flow between their vectors.
So words are sharing information based on relevance.
Precisely. And they often do this in parallel using something called multi-head attention, looking for different types of relationships simultaneously.
Okay, that's the attention step. What's the second step?
The second step is the feed-forward step. Here, each word vector, now updated with context from the attention step, sort of thinks on its own.
Thinks on its own.
Yeah, it processes the information it just gathered in isolation from the other words at this specific stage. It's often described as accessing a kind of learned database of facts or patterns associated with that word and its context, trying to predict what should come next.
So attention is about sharing context. Feed forward is about processing that context individually.
That's a good way to put it. The feed-forward layers contain a lot of the model's learned knowledge. Early layers might store simple facts about words. Later layers encode more complex world knowledge or reasoning patterns.
And this happens layer after layer.
Yep. Repeating these, attention and feed-forward steps allows the model to build up a really rich, context-aware representation of the input text. These internal representations, sometimes called hidden states, are just modified word vectors carrying all this context. And in big models like GPT-3, these vectors are huge, like over 12,000 dimensions.
12,000 numbers for each word's context.
Yeah, it's like a massive internal scratch space for the model to work out the meaning.
Okay, wow. That gives a much better picture of the how. It's complex, but the core ideas of vectors, attention, and layers make sense.
And remember the training. Getting all those parameters right involves showing it text, seeing its prediction, that's the forward pass. Checking how wrong it was, and then adjusting potentially billions of those parameters slightly to make it better next time. That's the backward pass using backpropagation.
Like tuning millions of tiny knobs.
Exactly. It's like trying to adjust every valve in a massive network of pipes simultaneously to get the water flow just right. Hugely computationally expensive. That's why training these models costs so much.
Right. And the scale is what makes them surprisingly good.
That seems to be a huge part of it. The sheer number of parameters and the vastness of the training data led to unexpected abilities emerging in models like GPT-2, GPT-3, and now GPT-4. More data, more parameters, better performance, often in surprising ways.
Okay, so we have these complex, layered, attention-using models trained on tons of data. Let's switch gears now to what they can actually do. What are the practical applications we're seeing?
Right, the fun stuff. The applications are, well, they're exploding, really.
Right.
Based on the sources like Liminalta and TechTarget, a huge one is conversational AI and chatbots.
Like customer service bots.
Exactly, but much, much better than the old ones. They can understand natural language, figure out your intent, have more fluid conversations, provide personalized responses, even handle sales chats, or act as voice assistants. It improves efficiency, consistency.
So more human-like interaction.
Definitely. Another massive area is automated content creation.
Writing things.
Yep. Assisting with marketing copy, writing reports, product descriptions, even drafting long articles. You give it a prompt, context. You can structure a response, maintain a brand voice.
That sounds incredibly useful, maybe a bit scary for writers.
It's definitely a tool that's changing things. It can be a great assistant for brainstorming or getting a first draft down. Then there's research assistants.
How so?
LLMs can process just vast amounts of text incredibly quickly, summarize papers, find key information, act as intelligent research tools.
Like that Google Gemini example you mentioned, analyzing tons of text.
Exactly. Summarization is a key capability.
Okay.
Taking long documents and boiling them down to the essentials. Super useful.
I can see that. What else?
Well, real-time language translation is another big one. They're getting very good at translating text between languages.
Better than dedicated translation tools.
Not always. Specialized models might still have an edge, but general LLMs are catching up fast. Also, automated coding assistants.
Writing computer code.
Yeah, helping developers write, debug, and explain code. Tools like GitHub Copilot are based on this.
Okay, that's huge for developers.
It is.
Yeah.
And sentiment analysis. LLMs can analyze customer reviews, social media posts, survey responses.
To see if people are happy or angry.
Basically, yeah, but with more nuance. Detecting emotions, tracking shifts in opinion over time. It gives businesses valuable insights into what their customers think.
So chatbots, content generation, summarization, translation, coding help, sentiment analysis. That's already a lot.
And question answering, too. You can ask them complex questions in natural language, and they can try to synthesize answers from the information they were trained on.
Though accuracy can sometimes be an issue, right? They can make things up.
Absolutely. That's a major challenge we need to talk about with hallucinations. But yes, the potential for answering questions is huge. And as mentioned earlier, this idea of tool use is expanding their abilities.
Connecting them to calculators or databases?
Right. Using external tools to overcome limitations. Like an LLM might not know the current time, but it can be taught to use a tool that does. Techniques like retrieval augmented generation or RAG help them pull in real-time external information too.
So they're not just text in, text out anymore.
Increasingly, no. They're becoming interfaces to other capabilities. So overall, they're becoming these really versatile AI systems for processing, generating, and understanding language across tons of different tasks.
It really does sound like they're becoming foundational in many areas.
Yeah.
But it can't all be smooth sailing. What are the hurdles, the challenges people face when actually trying to use these things?
Oh, definitely not smooth sailing. The Luminalta article points out several key challenges for businesses wanting to integrate LLMs. First, ethical considerations are massive.
Like the bias issue we touched on.
It's exactly. Mitigating bias ingrained in the training data is crucial. And data privacy. How do you use these models without exposing sensitive information? Plus, just ensuring accuracy and reliability. They can be wrong.
Hallucinations again?
Yep. So integration needs careful planning. Clear objectives, choosing the right model, figuring out how to handle bias, ensuring security, keeping humans in the loop for oversight.
Human oversight sounds critical.
It really is. And optimizing for performance versus cost is another factor. These models can be expensive to run. Continuous monitoring is also needed because the underlying models sometimes get updated by their creators.
And what about the folks actually building applications on top of LLMs, that Reddit discussion you mentioned?
Yeah, that highlighted some very practical, maybe less discussed pain points. People mentioned the reliability of response quality for complex multi-step tasks is still inconsistent.
So not always dependable.
Not for everything, no.
Yeah.
API costs can add up quickly, especially if you're using the more advanced multimodal models that handle images too. Then there's the challenge of validating the system when the base LLM might change underneath you without much warning.
Oh, like the provider updates the model and suddenly your application behaves differently.
Potentially, yeah. Data confidentiality is a huge concern for enterprises sending internal data to a third-party API.
Makes sense.
Also, just figuring out how to measure and optimize the quality of the output can be really difficult. What makes a good summary or a good answer? It's often subjective.
Tricky.
And of course, hallucinations came up. Again, the model just confidently making stuff up. Plus, some non-technical hurdles like organizational red tape or lack of incentives for adoption in big companies.
So a mix of technical, ethical, financial, and even organizational challenges.
Pretty much sums it up. It's powerful tech, but integrating it effectively and responsibly is non-trivial.
Okay, so challenges exist. Where is this all heading? What does the future look like? Any trends emerging?
Well, the annotation box source pointed to a few key directions. One is improved efficiency, finding ways to make these models smaller or require less computing power while keeping performance high. That tackles the cost and energy issues.
Greener AI.
Hopefully, yeah. Another trend is greater contextual understanding, getting even better at grasping nuances, remembering longer conversations, and generating more relevant responses.
So smarter conversations.
Right. and a continued focus on addressing ethical concerns, especially bias and misinformation. Techniques like reinforcement learning from human feedback, or RLHF, are part of that, using human feedback to fine-tune model behavior.
Trying to make them safer and more aligned with human values.
That's the goal. We're also seeing the rise of multimodal AI, models that don't just understand text, but can process images, audio, maybe video all together.
Like GPT-4's vision capability.
Exactly. That integration of different data types opens up tons of new possibilities.
Yeah.
And finally, maybe the emergence of more specialized reasoning models designed specifically for complex problem-solving tasks, going beyond just language prediction.
Interesting. So more efficient, smarter, safer, multimodal, and better reasoners. Sounds like quite the evolution ahead.
It's moving incredibly fast.
Well, this has been really insightful. So for you, the listener, hopefully this deep dive has, demystified LLMs a bit.
Yeah, cut through some of the hype.
They're powerful, text-focused AI models, incredibly versatile, rapidly evolving, but definitely come with challenges that need careful thought.
Absolutely.
Having this foundational understanding should really help you navigate the conversations and news around AI that, let's face it, aren't going away anytime soon.
For sure.
And maybe, just to leave you with something to chew on, given how quickly these LLMs are improving and integrating into everything from search engines to creative tools, what societal shifts do you anticipate? What excites you, or maybe what concerns you the most about where this is heading?
That's a great question. Thinking about that balance between automation and human skills,
Yeah.
the ethical guardrails we need, it's definitely something worth pondering as this technology continues to develop.